Last time we were together in Zoom, we learned a couple of basic differentiation formulas, and we're going to use them in this example here. I've got f of x equals x cubed minus 12x, and we are asked to find the equation of the tangent line to f of x at x equals 1. So this is something we've done before with the derivative, but it's never been this easy because we've never had these shortcut formulas before. All right, so let's remember our formula for the equation of a line, the one that we've been using anyway. All right, and we're given the x coordinate, the x1, that's just the x value that we're given, x equals 1. Our y1 value, that's the one that we get by plugging straightforward into the function. We're going to find f of 1. And then our slope, this is a tangent line, so our slope is, of course, going to come from the derivative. And we'll plug in x equals 1 there as well. All right, so let's go ahead and find f of 1. That's our algebra part. So we're going to go to the function. F of 1 is x cubed minus 12x. So we're going to do 1 cubed minus 12 times 1. And that's 1 minus 12, negative 11. So that's what I'll plug in for f of 1 over there on the left. And then we need the derivative. And here's the nice easy part, because now we know the power rule. So I'm going to come up here and say that this tells me that f prime of x, see, I'll use my power rule on x cubed. It's going to give me 3x squared. And then minus, we know that constants go along for the ride, constant multiples. So the 12 is going to go along for the ride. And we know the derivative of x is just 1. So we get 3x squared minus 12. All right, so anytime from here on out, unless I specifically ask you to use the limit definition of the derivative, you are always welcome to use these shortcut formulas. All right, so let's figure out our f prime of 1 down here. So we're going to plug into 3x squared minus 12. So we got 3x squared minus 12. So that gives me 3 minus 12. That gives me negative 9. All right, so let's plug in all of our numbers to our line. So I've got y minus y1, f of 1, we figured out was negative 11. So y minus a negative 11 is going to be y plus 11. And then my slope is going to be negative 9 and x minus 1. And then we'll just clean it up and make it look like a y equals mx plus b line. So distribute our negative 9 and get y plus 11 equals negative 9x plus 9, negative 9 times negative 1. And then I'm just going to subtract that 11 from both sides. Lots of negative stuff in this tangent line. So we got y equals negative 9x minus 2. And that's our tangent line. Let's go over to Desmos and make sure this actually looks like it works. All right, here we are in Desmos, and I've had Desmos graph me x cubed minus 12x, and it's a pretty big y coordinate function, so it's gone off my screen a little bit. So I'm going to shrink down the y-axis a little bit and see if we can see the shape better. Okay, there we go. And the point that we were looking for a tangent line at was at x equals 1, and we found the point 1, negative 11, which looks like that's exactly where it is. Let's go ahead and graph that 1, comma, negative 11. And there's my point of tangency, so kind of zoom in there. And then we'll graph our tangent line, and hopefully it looks like it's tangent there, which was negative 9x, and then that was minus 2. And that looks perfect. If I kind of zoom in there on that point, looks like we found the tangent line. Same function, different question. We're asked to find the x values at which f of x has a horizontal tangent line. All right, so let's think about using the derivative to answer this question. So a horizontal tangent line definitely the derivative can tell us about. What's special about a horizontal line is that the slope is equal to 0. So this is talking about lines where the slope is equal to 0. But because it's a tangent line, that means that the slope is the derivative. So this is where the derivative is going to equal 0. So anytime you're asked to figure out where a function has a horizontal tangent line, you're being asked to set the derivative equal to 0. So let's do that. So we already found our derivative, f prime of x. Again, derivative of x cubed was 3x squared minus the 12 goes along for the ride. Derivative of x was just equal to 1. And we want to set this equal to 0. And this is a quadratic equation. You could try to factor it or use the quadratic formula. This one has no x term in the middle, so we can solve this pretty easily by taking square roots. So I'm going to add 12 to both sides. And we're going to get 3x squared equals 12. Divide both sides by 3. And we get x squared is equal to 4. And just be careful when we're going to take the square root of both sides that you remember that plus or minus. So we're going to say x is equal to plus or minus 2. And they just asked for the x values, and there they are, x equals plus or minus 2. Let's go back over to Desmos and make sure that this makes sense by looking at the graph. Back over at Desmos here, I'm going to turn off our 2 points there and zoom this graph back out. All right. And it sure does look like at x equals 2 and x equals -2 that you've got those two places where the tangent line would go horizontal.